Okay, so let's say we are required to solve the equivalent resistance of this circuit. So the first thing that we really need to do is to just mark all the nodes in the circuit and make sure that you mark the nodes correctly, because if you mark them wrong, all the solution will be wrong. So let's just learn how should you know the nodes of the circuit. So the node is the point where the wires connect with each other. So this is the point where these all resistors are connected. So this is a single node. So let's name it an A node. So this is node A. So make sure that there is no resistor inside a node. So you can see there is no resistor inside this node, and they must directly connected with each other. So you must not include this wire with this portion. So if you connect this in this single node, so there is an element coming between them. So you should not include this region with this region. So this is a separate node, and then this is a separate node. So let's just name it node B. Then this whole thing is a separate node, so let's just name it C. And then this whole thing is the node D. So we marked all the nodes, so obviously this one remains. So this is node E. So now that I've marked all the wires, so you can see there is no resistor inside this node, there is no resistor inside this node, and this whole node is directly connected to each other. This whole node is directly connected to each other, and there is no component inside it. So similarly, I have marked all the nodes correctly. Now the second thing that we must do is to just write all the resistors here, R1, and in which two nodes these all resistors are connected. So this R1 is connected between node D and node C, so just write DC. Then we have R2, and this is connected between node A and node C, so just write AC. Then we have R3, which is connected between node D and node A, so just write DA. Then we have R4, which is connected between node A and E. Then we have R5, and which is connected between C and E, so CE. Then we have R6, which is connected between C and B. And lastly we have R7, which is connected between B and A. So all those nodes which are connected between the same pair of nodes are in parallel. So we just have to find the resistors. Like for example, this resistor is DC. So any other resistor which is connected between DC or CD, so this means that they are connected in parallel. So you just go through all the resistor and see whether you find DC or CD. So there is no resistor connected between these two nodes, so there is no resistor in parallel with this R1. And then if we see AC, so there is no AC or CA. Then DA, so there is no DA or AD. Then AE, so there is no AE or EA. CE, there is no CE or EC. CB, so there is no resistor that is connected in parallel with each other. So that means all these resistors are either connected in series or they are in the Y or delta form, which is neither a series nor parallel form. So there are three forms, whether the resistors may be in the series, in the parallel, or in the undefined form. So they are in the series or maybe in the parallel. So for series, you just have to check. So let's say this is our resistance and this is our another resistor. So two resistors are connected in series if their starting point is a single starting point, and let's say we enter this resistor from this path and we exit the other resistor from this path. So there is no other point of exit from these two resistors, so means they are in series. So if I enter this resistor and I exit only through one path, then that means they are in series. For example, if I have a wire here like this and I say find the R equivalent through this point, so what do you think, if they are in series or in parallel? So no, they are not in series because this is our reference point. So if I enter this path, I have a path going through, entering through this region as well. So I can exit here or I can exit here. So I have two paths. So that simply means that they are not in series. So if we don't have this region and we are just comparing here, so now if I enter it here, I can only leave this resistor from this path. So I just have a single path, means they are in series. So looking at that, if we now see, so if I enter this resistance from this path, I will exit this R6 from here only. There is no other path in between, so I cannot exit from this point, I cannot exit from this point, neither they have asked the R equivalent from this region. So if I enter here, I can only exit this, so means these two resistors are in series. So I can just remove this whole thing and just write 130 resistance in this portion. Okay, so this is 130 ohm. So I've removed R6 and R7. So I've removed R6 and R7, so I can remove these two resistors from here, which is now replaced with another resistance of equivalent resistance of 130. So we now have this resistor, and this resistor is connected between node C and node A. So we can just write that 130 ohm is connected between C and A. So now I just have to compare again by the same method that I have told. So DC, there is no DC or CD. AC, so obviously now it is AC and AC. So we have a pair, a common pair in R2 and this 130. So means they are in parallel. So I have told you that if you find AC or AC, or either AC or CA, means they are in parallel. So I can replace these two resistors with a single resistor. So R2 is in parallel with 130 ohm. So if you look at this circuit, you will not find out by just looking at this that these two are in parallel. So if you write it in this format, you will know that these two are in parallel by this method. You can see, if you are to see this circuit manually, you will not find out that. If you are a beginner, you will not find out that this resistor is in parallel with this resistor, but now you are able to know that these two are in parallel. So just solve them, and the result will be, let me solve it. So 20 multiplied by 130 divided by 150. So we have 1.15. Okay, so we have 17.3. So we have 17.3. So all we have to do is to just remove one resistance between. Either we remove this resistor or either we remove this resistor. It's our choice. we have to just remove one of the resistor from them and name other one to the result that we have obtained. So let's say I just remove this resistor because this is easy for me, this is inside the circuit. So if I remove this, so a little bit confusion will arise. So let's see, I remove this resistor from my circuit because I have solved it, so remove it completely. Okay, so now that I have removed this, but I know that this R2 is no more than 20 ohm resistor, so this R2 is now a 17.3 ohm resistor. So just rename it to 17.3. So now, so this is 17.3 ohm resistor. So now if I remove this one, because I have removed this resistor, so I can now remove this from my data as well. I'm just left with 4 resistors, and we know that there is no other parallel combination here. There are no common pairs, so I just have to find for the series network. So if I enter this R4 from this point, so I can end R5 from this point, and we have no other path to exit, so it means these two are in series. But if I enter R2 here and I exit R5 from here, then we have this part to exit, so these two are not in series. So you just have to understand this point. This R2 and R5 are not in series, because if I enter this point here, I can exit either from here or either from here, so there is no single exit to these two resistors. But if I enter this R4 here, I can exit this R5 from here, and there is no other point in between where I can exit, so it means these two resistors are in series. So I can just remove these two resistors and just replace them with a single resistor of 90 ohm. So just remove it, just write 90 here. Okay, so R4 and R5 is replaced with a 90 ohm resistor. So I've just written, just need to replace these two because these two are no more, and we have just a 90 ohm resistor which is connected between A and C. Okay, now I can see that this AC is common with this AC, so means these two are in parallel, but they are no more parallel combination. So I can solve these two to obtain a parallel result. Okay, so, and I know that this R2 is now equal to 17.3. It is no more equal to what its initial value was. So what I can do is just solve these two. So R2 is in parallel with 90 ohm, which I just obtained. So the answer will be 17.3 multiplied by 90 divided by 107.3. So this is 14.51. So what you have to do is to just replace one of the resistors from them. So we just need to replace one of the resistors among them. So I just, let's suppose, replace this one, remove this one, sorry, and retains the other one, and its value is now not the 17.3, but its value is actually 14.1 because I have solved it parallelly. So it is now 14.51, and obviously this R3 is now, sorry, this 90 ohm is now no more. I removed this resistors, so this pair is also removed. So I just am left with these 3 resistors, and they are not in parallel because I don't find any common pair. There is no DC DC, there is no AC AC, there is no DA DA. So I just have to look for the series combination again. So if I enter here in this R1, let's say I enter this R1, so I can exit this R2 from only a single path. There is only a single path, there is no in between path, so means these two are in series. But let's say if I enter this R3 here and I exit this R2, let's say I enter this R3 here and I exit this R2 from here, there is a in between path, and this is the in between path. These are equivalent, so these two are not in series. But if I enter this path here, I can exit here this, and there is no in between path. Or either I enter this path, I can exit this. So these two are in series, so I can just remove these resistors and replace them with a single resistor by adding these two. So 24.51 will be my equivalent resistance of these two, and that equivalent resistance will be connected between the same nodes. So this is now 24.51. So this is now 24.51, and this, so as this R2 and R3 is removed, sorry, this R1 and R2, I've solved this R1 and R3, sorry, in fact I've solved R1 and R2. So R3, I didn't change this R3, so R3 is still in between DA, so only R1 and R2 is replaced with 241. So we just have to write 24.151, and it is between DA. And now we can see that they are in the same pair of nodes. If they are DA or either AD, they are in the same pair of nodes. So these are in parallel with each other. So just solve them parallelly. So if I solve them parallelly, then 24.51 multiplied by 30 divided by 54.51. So it is 13.89. So 13.89. So I just have to, in parallel combination, what we do is we remove one of the resistors. So I just remove this one resistor, and this R3 is now equal to an equivalent resistance. So this is now an equivalent resistance, and its value is 13.49. So this is how we solve the series parallel combination. These two are because we have solved them parallelly, so they are finished. So this is how we solve the series parallel combination. This is the most easiest method if you are not expert at electric circuit analysis, and if you are a beginner, so you just have to follow this method and you will never did a mistake in this. So if you have any question, you can ask in the comment section. I will answer you. So thank you for watching this video.